Hello students. Let us do an example with factorials. Now I could grab factorial from a library like SIMPy has one and the math library has one too, or I could make my own. Let's make our own here if I can get this out of the way. Let's call it fact. A little abbreviation there. And what I'm going to do is I'm going to return 1 if n is equal to 0, else n times fact n minus 1. And if I wanted to save a little bit space, I could have done 1 if not n, though that really actually doesn't save any space at all because not n takes more characters. I guess if I did that and I replaced it with not space n, I would save a single character. Let's do that. Let's save that one character. And let's show you that this works. So if I wanted to compute fact 3, what's this doing? Well, we can see here what it's going to do is it's going to take 3 times fact 2. Then in order to get fact 2, it takes 2 times fact 1. In order to get fact 1, it takes 1 times fact 0. So, and that gives me the 1. So we put all that together, and this should give me 3 times 2 times 1, which is 6, which I get as well. And I could also do fact 4, or even something like fact 24. For fact of fact 4. Okay. So let's make a list of these. So I'm going to do fact n for n in range 10. And I noticed something about the sums of the digits here. The first 2 are odd. The next 3 are even. But from then on, it's all odd. 1 plus 2 plus 0 is odd. 7 plus 2 plus 0 is odd. 5 plus 0 plus 4 plus 0 is odd. So I'm getting all these odd sums. I want to investigate that. So let's make some functions to do that. So let's find maybe some sums of digits. But in order to do that, maybe I'll come up with a function digit list to start off. Digit list. Yeah. Okay. So what I'll have it do is in order to get the digits out of a number, I could turn it into a string. I could turn that into a list. So I get list string n. And this works very nicely, but I don't like it. Why don't I like it? Well, because the numbers in here are actually characters. There's these little size 1 strings. I want actual numbers in my list. So what could I do? Well, I could deal with this in 2 different ways. One thing I could do is, well, we know how map works now. So let's map these through a function that would turn them into integers. What turns them into integers? The int function, the built-in int function. So I'll take a map, and I need my function, which is int, and then my iterable, which is there, and I'm going to apply that. And I guess the thing you might not like here is that it doesn't actually tell you right away. It gets the process ready, right? Lazy evaluation. So if I really want the list immediately and I want to see everything that's in it, which I might not, that will work nicely. So what did I do here? Well, I take a number, I turn it into a string so I could grab the characters, I turn those into a list, and then I map those characters into the int function one at a time and create a list out of that. So this works nicely. I could also do this sort of without the map function, though I like the map function, especially in this section. But let's say I wanted to do it without the map function. Well, I know what this gives me, right? This gives me these sort of characters. So what I could do is I could say, okay, give me the list of int I for I in this list of characters. And this will work too. So both of these work nicely. Notice that both of these store all the characters in memory at once. What if I wanted a way to do this that did use some sort of a lazy evaluation, didn't compute things right away? Well, if I don't need to see them immediately, and I'm not going to if I want to sum them up, one thing I could get rid of is that. But you see here, here I am listing all the characters of this string. So what I could do is I could just do this map of, I could make this a generator, I for I in. So now what am I doing? Well, I'm turning my number into a string. I'm grabbing the individual characters from that string, and I'm mapping them through int. At no point am I storing this all in memory, other than the fact that I have to feed it an n here. So this isn't stored at memory all at once, and this isn't stored in memory all at once unless I ask it to be. So let's try this. So digit list. Oh, and I shouldn't call this digit list anymore because we're not using list. Let's call it gen. Digit gen. 3344. There we go. Digit gen. And it's not defined because I didn't hit enter. Okay. And now, if I want to, just for bug testing to see if it works, put that into a list, you could see that it is in fact working. But we're never going to need to list this out if we want to put this into a sum. So let's make a sum of digits function. So sum of digits for n, what we're going to return is the sum of digit gen. So now I never had to store them all in the list at the same time. So sum of digits, and I do 3, 4, 5, and I get 12 because 3 plus 4 plus 5 is 12. Okay. But what I really want is I want to see if the sum of digits is odd. So odd digit sum. So I want true or false for the outputs here. And what I'm going to do is I'm going to return, well, whether or not the sum of digits mod 2 equals 1. And now I can check for odd digit sums of, let's say, 1, 2, sum of digits. Oh, I forgot to write my n. There we go. So odd digit sum 1, 2 is true, 1, 3 is false, 1, 4 is true again. So this is working nicely. But as a matter of fact, I could get rid of that. No, actually I can't. Well, I wanted to return true or false. I can get rid of that, but I think it sacrifices a little bit of clarity because I want this to be a true or false for my filter. My filter will absolutely work with zeros and ones, so if I get rid of that, it will still work. But let's keep it as true or false. I like it better, at least for instructional purposes. Okay, so now we're finally getting to the end. So I want to keep the factorials that have odd digit sums. So one thing I could do is I could start small, and I could say, you know, I for I in this if odd digit sum high. And this gives me the ones with odd digit sums, and you'll see it got rid of things like 6 and 24 and so on. And let's go a little further. Let's see if in fact I'm going to get what I'm going to get here. So here I'm getting the ones with odd digit sums. Well, let's see, am I getting all of them? Let's see the ones that don't have odd digit sums. And yes, actually it's not always going to have an odd digit sum as we go on, because this has an even digit sum, 3, 9, 9, and 1. That gives me an odd number of odds, and this has a 3, 7, 3, 7, and then a 5, 7. So it was a conjecture. We tested it, and it turned out not to be true, but we got to play with some maps and filters along the way.